Hey, everybody. Welcome back to, I guess, for most of you, what'll be your last week of the school year. Um, and when I say that because most of you are all caught up with turning stuff in. And I assume that you're probably in the same situation in most of your classes, in which case Friday will be the last day of instruction. And for this class, it's going to be a test. So we're just warming up for that, getting ready for the Conics section test. It is not a cumulative final exam. It is just a test over the contents of this last chapter. So circles, ellipses, hyperbolas, and all that stuff that goes with them. So to start the review today, we're going to take a look at a whole bunch of equations. I've actually got 6 equations to look at. And I have made these equations extremely similar to each other. So even though you're looking at 6 different equations, you see a lot of things that they've got in common, um, but some things that they don't have in common. Some of them have minus instead of plus, um, which we'll talk about what that means. For many of them, the coefficients on the x and y terms are different, but for some of them, they are the same. We'll talk about what that means as well. So for each of these problems, we're going to switch them around so that they are in standard form, so it's more recognizable. If I give one of these to you right now and ask, is this a circle, hyperbola, or ellipse? You may not know. So we'll switch it around to a form that's more familiar. We will find what type of conic section they are, find the coordinates of the center. Um, and for the foci, we'll do that for the ellipses, but not for the hyperbolas. The rest of the teachers have been talking about this, and a hyperbola does have a focus or 2 foci, and it's not too difficult to find, but it's just something that we're choosing to skip because frankly we're running out of time. So if you're really curious about that, go ahead and look it up on Wikipedia or in your textbook or on YouTube or ask an older sibling. Don't do that last one, they probably won't remember, but you can look it up if you would like to. And then vertices, co-vertices for the cases where we have them, and then sketch the graph. So we'll start with this one. 25x squared plus 9y squared equals 225. And actually, I think this might be similar to one that we've already done. I am going to take this equation, and to get this one into standard form, I'm going to divide everything by 225. Because these coefficients are not the same, I know that it's got to be either an ellipse or a hyperbola. Because this is a plus, I know it's going to have to be an ellipse. So the standard form is going to be something plus something equals 1. Now, when I divide by 225, 9 goes into 225 25 times, 25 goes into 225 9 times, and so we'll get an equation that looks like this when it is simplified. Then graphing it, first, I guess we should identify that this is an ellipse. And so as I'm graphing my ellipse, I look at the x squared term. The denominator of the x squared term is a squared. And so a is 3, which means our horizontal distance to the ellipse is 3 in both directions. By the way, the center, of course, is 0, 0, because it's just x squared and not x plus or minus something squared. Similar for y, the value of b is the square root of 25, so we will go up 5 and down 5 to get to those points. As far as the foci, we'll do the focal distance is b squared minus a squared to get 16, and then that distance, or that number, is the focal distance squared. So up 4, oops, a little ambitious with my focus there, and down. So these are the points. If I had a string, I would hold that string at those endpoints, and then if I draw and trace around, I would make the form of the ellipse that's going to end up looking like that. So there we go. I think I've identified everything that I want to identify with this one. So we'll keep going. Next, I've got something for which the coefficients are the same for both of these. So this one is not an ellipse. This is actually going to be a circle. You could think of it as an ellipse that has equal length for its major axis and minor axis, but that just means that instead of an axis, I have a diameter of a circle. So the standard form for a circle is going to be x squared plus y squared equals something squared, which means in this case, I'm going to divide everything by 25. Um, because I need the coefficients on the x squared and the y squared to be 1. And then, of course, 225 divided by 25 is 9. And so there we go. X squared plus y squared equals 9. My center is 0 because it's just x squared and not x plus or minus something squared. My radius is 3. So over, up, down, left to right, 3 to get the significant points for the circle. And there we go. Next one we have is similar to the first one we did. Coefficients are different, so I'll divide both the left side and the right side by 225 to bring myself into this form. This is, again, similar to one that we've done before, so I'm going a little bit more quickly. I'll identify the horizontal axis by looking at the square root of the denominator of the x term, the length to the vertical part of the ellipse, up and down by the square root of 9 or 3. The focus is going to be the same value, the distance for the focus, but because our major axis is the horizontal axis, I'll go to the left by 4 and to the right by 4 to get to those points, and then finish graphing that ellipse. Again, going fairly quickly because it's one that we've basically done already. Next, here's our first minus sign, which means we must be looking at a hyperbola, although I will give a word of caution in your assignment. There will be some different rearranging of the equation that you're going to have to do. My x and y are both on the same side of the equation already, and if I had to do a little bit more algebra, there'd be a little bit, well, different ways switching it around. But in this case, I am going to divide everything by that same 225 that I did before. So 25 over 225 will reduce to x squared over 9. 9 over 225 reduces to 1/25th. And of course, 225 over 225 is 1, which is why I'm doing it, getting into the standard form for a hyperbola. First one we're taking a look at today. So a reminder after a long weekend of not doing a whole lot of mathematics, I'm guessing. The x squared term is the first term, which means I'm looking at the vertices to be the distance of the square root of 9, the distance of 3 away. They are horizontal, and these are actually points that are on the hyperbola. Up and down by 5 because of the 25. The square root of 25 is 5. And so these points I'm going to make a little bit lighter because they're not actually points on the hyperbola. They are the co-vertices. But I'm using them more for guidance in creating the rectangle around which I will then make my dotted lines, my asymptotes, which will look, let's see, about like that. And then for drawing this, I know that the graph itself goes through these vertices, straight up and down, approaching the asymptotes. And I took my time earlier and made a slide that looks a little bit better than the one that I was in the process of making to make a hyperbola that looks like this, a hyperbola that opens to the left and to the right. And nothing more to say about that. Moving right along, here is the other hyperbola. In this case, the y squared term is coming first. So I'll do the same dividing by 225 manipulation that I did previously. But now, because the y squared term comes first, I'm looking vertically, going up by the square root of 9 or 3, going down by the square root of 9 or 3. And now these points are the vertices, points through which the hyperbola will actually go horizontally by the square root of 25. So to the left by 5 and to the right by 5. These are my co-vertices, but they are not actually on the hyperbola. Again, making my points for reference for drawing the asymptotes. Let's see. Oh, I don't want that. So one asymptote going that way, another asymptote going this way. By the way, the equations for these asymptotes, the slopes are either positive 3/5 or negative 3/5, but they go through the origin. So just simply y equals plus or minus 3/5 x. And then drawing this curve, again, horizontally through that point, approaching the asymptotes. And I took my time and did a better job earlier, so I'll go ahead and skip to that. And I've got a hyperbola that looks like this, opening up and down with the shape that you can see. And then finally, one last one. This one is similar to the second one that I did. The coefficients are the same, which means I'm going to divide both the left and the right side by 9, because I don't want this to be equal to 1. I want these coefficients to be equal to 1. In this case, getting x squared plus y squared equals 25. So this is a circle with a radius of 5 centered at the origin. So up and down and left and right. I will take this opportunity to remind you that we have a Pythagorean triple where the hypotenuse has a length of 5. A 3, 4, 5 triangle, legs length of 3 and 4, hypotenuse of 5 means I can get even better with my drawing, and I can go over by 3 and up by 4, over by 4 and up by 3, and I can make this graph even better. I can also notice that I put that point in the wrong spot. Counted to 4 instead of 5 to get to that point. Let's see, over 3 down 4, over 4 down 3, and then finally over 3 up 4, over 4 up 3. And that gives me a few more points for when I play connect the dot, but I'm going to go ahead with the slide that I had prepared that's got my nice circle with a radius of 5. So there we go, getting back into the swing of things, getting back into our final week. Again, your worksheet's going to be a lot of this, just manipulating, getting things into the standard form to identify what type of a shape they are. And then tomorrow or I guess, gosh, it's Tuesday. So, well, I'll probably put the review assignment up for you guys to start working on before Thursday. Some of you may be anxious to get started on that and get everything cleaned up so you don't have to worry about that on Thursday night. So I'll put that up either today or tomorrow, but you will have access to that. There we go. That's all we need to do today. I will, you may tell I'm kind of hesitating. There's a topic that I was considering covering called completing the square, but I think I'm gonna have to skip that for now. Maybe I'll put it up as a bonus topic or something like that for you guys to take a look at. But I think I need to force myself to cut it off at this point, and just continue with what you need for this class. If you're interested in looking up completing the square, I welcome you to do it. It's a cool topic, not necessary for this class, but something that might be interesting at this point. All right, that's enough for today. Hopefully you had a great weekend. Hopefully you are ready for your last week, and we will talk to you later. Bye-bye.